This is section 5.1, problem 12. For the function below, state the key characteristics: domain, vertical asymptote, horizontal asymptote, vertical intercept, and horizontal intercept. Our function here is f of x equals x minus 4 over x plus 2. So we're going to start with part A, finding the domain of this function. To find the domain of a rational function, we want to find the zeros of the denominator and exclude those from the domain. Our denominator here is x plus 2. So if we set this equal to 0 and solve, we get x equals -2 as the zero of the denominator. So the domain would be all real numbers except x equals -2. All right, so that is our answer for the domain. On to part B, finding the vertical asymptote. When you find the zero of the denominator, you actually end up getting two things. One, if that number is not a zero of the numerator, then it also tells you where the vertical asymptote is. And then as we just saw in part A, it tells us what number is not in the domain. So using what we found in part A, we also know that the vertical asymptote for this function is x equals -2. Then that brings us to part C, finding the horizontal asymptote. To determine the horizontal asymptote of a rational function, we want to look at what happens to the function's outputs as x approaches positive infinity and as x approaches negative infinity. In order to do this, we're going to use our graphing calculators and the table feature and explore how our outputs change as x becomes infinitely big and positive or infinitely big and negative. So let's jump over to our graphing calculator to do that. All right, so now that we're in our graphing calculator, we want to first enter in our function. Under y equals, we're going to put in x minus 4 over x plus 2. So parentheses, x minus 4, close our parentheses for our numerator, and then divide it by, open up another set of parentheses, x plus 2, and close out the parentheses again. We want to, again, explore what happens as x gets really big and positive and really big and negative, and we're going to do that using the table feature. First, we're going to go to table set, so press second and then window. We want to know what happens as x gets really, really big, so we can let the table start at 0 and then let delta table increase by 1,000. So we're going to look at the inputs 1,000, 2,000, 3,000, 4,000, and so on. And we're going to scroll down the table to see what the outputs look like and see if we notice a pattern. All right, let's go and look at our table. All right, here we see, we scroll down this table, as the x values get bigger and bigger, the y values are increasing. We have 0.9991, 0.9993, 0.9994. And the values are getting bigger and bigger and bigger and closer to 1. So it looks like as x gets bigger and approaches infinity, the y values are getting closer and closer to 1. We should write this notation to say, let's see if we can write this down. As x approaches positive infinity, the outputs, or y, approach 1, okay? Now we also want to know what's happening as x approaches negative infinity. To figure this out, we're going to go back to table set, and instead of letting our delta table be 1,000, we're going to look at -1,000. So our numbers are going to get more negative, so really big negative numbers, and we're also going to start at 0 again. And then look at what's happening to the outputs. When we go back to the table, notice now we're at 0, -1,000, -2,000, so -3,000. Our inputs are getting more and more negative, and our outputs are getting smaller and closer to 1, 1.006, 1.003, 1.002, 1.0015. As we keep going, 1.004, or 1.0004, I'm sorry, 1.0003. As we can see here, the y values are getting closer and closer and closer to 1. So as x approaches negative infinity, y is approaching 1. These results that we're getting, we see that y is approaching 1 in both cases. This tells us that we have a horizontal asymptote at y equals 1. All right, let's go back to our workbook and write up this solution. Okay, so from the work we just did in our graphing calculator, we saw that the horizontal asymptote is the line y equals 1. On to part D. For part D, we're asked to find the vertical intercept and write the answer as an ordered pair. To find the vertical intercept, we're going to let x equal 0 and solve for the output y. So if we look at f of 0, that would be 0 minus 4 over 0 plus 2. Negative 4 divided by 2 equals negative 2. So when the input is 0, the output is negative 2. That gives us the ordered pair 0, negative 2. This is our vertical intercept. And lastly, to find our horizontal intercept, we're going to take our rational function and set it equal to 0. But in order for a rational function to be equal to 0, that just means that the numerator of the rational function is equal to 0. So if x minus 4 over x plus 2 equals 0, this just gives us that x minus 4 must be equal to 0. And then if we solve that, we get x equals 4. So when x equals 4, we get an output of 0. That gives us the ordered pair 4, 0 for our horizontal intercept. So for the function f of x equals x minus 4 over x plus 2, our domain is all real numbers except x equals negative 2. We have a vertical asymptote at the vertical line, x equals negative 2. We have a horizontal asymptote at the horizontal line, y equals 1. Remember, that means as our x values get really big and positive or really big and negative, the function gets closer and closer to 1. We have a vertical intercept at 0, negative 2, and a horizontal intercept at 4, 0.